week is a little, this one is a little confusing to me.
Yeah.
Not a ton, but a little. So we'll see.
Let me find where we are.
And there's a spreadsheet you have to open, so.
I have been working on this describe the data stuff, so I haven't looked very much. I looked a little bit, but not very much at the work for this.
Yeah.
Let me see.
We did well. It looks good.
Yeah, thank you very much. And we got 100% on
Yeah, I noticed that.
the last one, so that's great.
Oh, good. I didn't look.
I like that.
Good.
Yeah.
That means that means we're on the right track. So the final should be right.
Yeah, exactly. I think so too.
Yeah. Okay. Do we all have it? Just plugging in the numbers.
Yeah, I have it.
Okay. I'm in the spreadsheet.
I have so many spreadsheets open right now.
I know, right?
I know.
And for these, we use a linear regression, right?
Yes.
Okay. Just making sure. I'd hoped to have more time to work on this, but I ended up having to drive 5 hours today, this morning.
Oh my gosh, what for?
Well, we were meeting a friend. My girls wanted to go stay at a friend's house, and they live about 5 hours away. And so we met halfway, which was really nice. But I was like, I'm going to have some stuff to do. But it's fine because now I'm quiet. Well, it means 4 of my kids are gone. So for a week and a half, I have like tons of time to work on all sorts of stuff. So that's good. I'm hoping to finish up most of the semester. That's what I'm hoping.
Hooray.
We shall see.
What did you guys register for fall?
I did.
What are you taking?
I'm actually in that spreadsheet class you guys have been talking
about.
Oh boy. Good luck.
Not excited, but
you know what? You're going to learn a ton. But like last week, we had a test, and still my past test hasn't been graded. So now I have 2 tests ungraded.
I know. That so much.
You don't know how you're doing.
It is right or wrong. Yep.
Yes.
I'm not impressed with that instructor.
No, me neither.
Chelsea Cochran.
I've decided, my husband and I have decided that I'm not going to finish my degree after all.
Really?
So, yeah, it's just too much. I've been going for a long time. I went to Pathway in 2012.
Yeah.
And so I've just been taking like 1 class at a time, and then take a semester off and then take another class or 2. Yeah. And so I took 3 classes this semester, and it's just way too much.
Yeah.
But for me to be able to finish before my catalog year is done, I would have to like take a bunch of semesters like this between now and 2020, and it's just it's not worth it right now. Well, so
later in life.
Yes, I'm sticking out this semester because I was really tempted to just drop everything, but I'm like, I really can't because I'm doing good in the classes.
Yeah.
So
you might look at the grades and the and then when you come back, you'll have those. So
I'll probably take 2 more classes still because I want to take I want to learn about business law and about financing small ventures. So I might just take those classes just for my own information because I want to learn the stuff. So
good for you.
Okay.
Well, life can be long, and there's lots of time. You have to prioritize what you do right now. So there's nothing wrong with that.
Well, I started realizing that most of my teenagers would be you know, who are teens now would be gone in a few
Mhm.
years. I'm like, I don't know if it's worth trading
Yep,
time.
I agree.
You know, that can't be.
Teenagers
I
need you
can't
more
get
than
that
any.
time back.
Yeah, that's hard.
I agree.
And I don't have to work right now.
Probably a good decision. So.
All right. Sorry, that was
All right.
long.
Yeah, you're good.
That's all.
No, that's okay. Question 3. Given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept? So I believe the y-intercept is 2.0
Mm-hmm.
Yes.
because that's
we'll put
b
point
0,
zero.
right?
Mhm.
Yeah, you don't have to put the 0. 2. Yeah.
Just in case.
And then question 4, given the linear regression equation y equals 2.0 plus 1.5x, what is the slope? And that would be 1.5.
Mm-hmm.
And then 5, given the linear regression equation y equals -3 plus 0.25x, what is the predicted value of y when x equals 16? So 0.25 of 16 is 4. So -3 plus 4 is 1. So y equals 1.
Nice math in your head.
Yes.
I like equations.
That's pretty good.
All right, someone else jump on in.
Okay, I'll take it.
Okay.
Oh, good. A new spreadsheet. Oh, no, it's the same one. Okay.
Same
we're
one,
good.
yeah.
It's like, wow, really? Okay.
We didn't do anything with the last one,
Yeah.
right?
It says make a scatter plot of the math self-efficiency data. Of the 3 data shapes, which shape best describes these data? I didn't even read about these,
Okay.
so I'm not sure.
Well, it's kind of, you can tell, the hot dog shape.
Yeah, I'm like,
Oh my goodness,
I
is this
remember that
legit?
Yeah, or the
This is
hamburger
science.
shape,
This is
or the
scientific.
banana. Yeah, this is scientific. So I think it's the hot dog shape. What do you say?
I mean, that's what it looks like to me.
Looks
But
like a hot dog. I should have read the lesson.
that's funny.
Okay.
All right. So 7, based on the shape of the scatter plot you produced, and the last question, what can you say about the appropriateness of using simple linear regression to model these data? So does it need to be a certain shape or one of the shapes?
Yeah, so for hot dog, you can use it because it's a straight line.
Okay.
For hamburger, it's too scattered, so you can't, it's not appropriate. And for the hot dog, if it's curved, it's not appropriate because it's non-linear then. So
curved
those
is
two
banana?
are kind of linear. So yeah, no banana, no hamburger, but the hot dog is linear, so.
It is appropriate.
Okay. So it is appropriate, right?
Yes, I believe it is.
Okay. 8, how many observations are in the data?
Well, let's see. Looks like 142 minus
3.
3. So what is that? 139.
139.
Okay.
Nice. These aren't bad so far.
Not so far.
9, what is the y-intercept?
Okay.
Is that
So it's right there in the center in G13.
uh-huh.
It says y-intercept.
Oh, yeah. Okay.
So the B is
1.296.
1.296 looks like.
And then the slope 0.042.
Yep. Look alike it.
Okay, what is the predicted value of y when x equals 4? So,
Yeah, so we go to G.
1.296, right?
Well, you're
Plus.
going to use the table. No, you're going to use the table. So in the table in G17, there's an X.
Okay. Oh, yeah.
You put the number in below the X. So what did they say?
Oh,
6?
you can just do that.
4.
Yes, okay.
X equals 4.
Oh, is it 4? X equals, but is that what they told us to put in, 4?
4, yeah.
Yes.
Okay. And then next to it is the predicted.
Okay.
So 1.462 is yeah. Yep.
Yep.
1.462.
Okay, you want to take the last one, Susan?
Sure. Oh, I'll take it. The confidence data results from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Because there's a positive correlation, we can use the largest x value to find the largest predicted value.
So I think we look at the table, and the largest predictive value, or the largest value of x would be 100, right?
Yeah, it looks like it.
So because it's a test, and that's the score of a test, so the highest score would be 100. So if we put that in the if we put 100 in,
For x.
give us the prediction.
Ah,
So it looks like 5.469.
okay.
Yeah, that's what might show.
But who knows if that's right. This seems right.
Yeah, it does.
But
Okay.
we'll see, won't we?
Yeah. How many explanatory or independent value variables are present in simple linear regression?
So the independent variable is y,
Yeah. So there's,
right? So would it be 1?
yeah, just one.
I think so, in a simple linear regression. Because otherwise it would say multiple,
I think so.
So you
right?
said it's y?
Yeah, so, yeah, because y is the, oh no, sorry, x. X is the explanatory variable, but it's still, there's just one.
Yeah. Okay.
And then how many response or dependent variables are present in the simple linear regression?
And I
That
think
one
that's
as well.
Just one also.
Yeah, because if x is this, y is this, right?
So when you look on the left of there's explanatory variable, response variable, and then another explanatory variable. But
Yeah, but that
just,
I think is just for spreadsheet basis. That's just moving the information over.
okay, yeah.
So it does a calculation. I don't think it's a,
Another one.
yeah, I don't think
Makes
it's another
sense.
something. So now this didn't ask us at all the R. What's the R stand for? The something regression something, but it didn't ask us for that, right?
No, it hasn't.
Okay.
A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and length of the major and minor axis, meaning the company wants to predict the size of the hat given the circumference. What is the response variable?
So what's the thing that depends on something else? So it says they want to predict the size of the hat. So the response variable is what's being predicted. If we have X, we'll get Y.
So if
the
they have the
response variable is,
then they have the size.
yes. Right. So I think it's the first one,
Yeah.
because the second one is not correct, because we're not predicting circumference. The third one is not correct because, again, it says the size of hat because it is being used to predict. Opposite. It's opposite. And then the last one is the circumference because it's being used to predict the hat size. It is being used, but it's the explanatory variable, not the response variable.
Okay.
So I think the first one is the right answer.
So the response variable is what's being predicted.
Yes,
Okay.
exactly.
Okay.
So if I'm given something, how does that other variable respond? What's going to happen to it?
Okay.
If I get taller, then I get thinner or something, you know.
Yeah.
If only it was that easy.
If only. That's
I
the
just
problem.
need
I'm
2 more
too short.
inches. Yes, me too.
Oh well. All right. You want me to? Since you want me to submit here?
Sure.
I can do it.
Hold tight.
It's been a while.
I'll do it.
Sure.
Hold tight. I'll do it. Yeah. I don't mind. We'll see. Ooh. 13 out of 17. Terrible.
Oh.
What?
Really bad.
Okay. Which one?
I don't know how that can be.
Huh.
All right.
Seems weird.
The first, yeah, I know. The first one is right. Second one's right. Of course they are. Okay. Number 3 is correct. I'm going to write them down right now while I'm.
Okay.
So number 3 is correct. It's a 2. Number 4 is correct. It's a 1.5. Number 5 is correct. It's 1. Number 6 is correct. It's hot dog.
Phew.
Number 7 is correct. It's simple line regression is appropriate for these data. Right? That's what we all had, the first one.
Yes.
Mm-hmm.
Then number 8 is correct. How many observations? 139. Number 9 is wrong. What is the y-intercept? Seriously?
Okay.
So number 9 is wrong. Number 10 is wrong. What is the slope? Number 11 is wrong. What is the predicted value of x or of y when x is 4? I don't know how that could be wrong. It's in the spreadsheet.
Yeah.
Huh.
That's
We must have done something wrong. And then 12 is wrong because it says, what is the maximum predicted value of y for these values of x? That's wrong. So
Okay.
9, 10, 11, and 12 are wrong.
So if we figure out 11, we'll probably get 12 right also, because those are
Yeah.
the same.
Well, yeah. All right. So what is
the y-intercept.
Let's see. How could this be
Yeah, that is
wrong?
just weird to me.
Let me see. It says something about, oh, I did it too little. It says in the question up
How
here.
can number 9 and 10 be wrong?
Okay, it says be sure to use the confidence data for the explanatory variable. Oh, maybe we flipped them. That's why. It says be sure to use the
Did we?
confidence data for the explanatory. So X needs to be, the data needs to be flipped.
What do you mean?
See what I'm saying? When we put it in the chart,
Mm-hmm.
Yeah.
we put the data in the wrong place.
We put it in backwards.
We put
So
it
like
in backwards.
So the top data should say the X should be 4.34.
Yes.
And the Y should be 50.
Yes.
Okay.
All right. So fine.
We just, okay.
That's why.
All right. Let's just do it again.
Yeah. Maybe it'll change. That would be nice, wouldn't
I know.
it? Except I still don't know then how to answer number 12. Because that shouldn't have made a difference, but maybe it does. Control. Oh, shush, you old thing, you. All right, hold on. Let's see.
The spreadsheet just froze up. Darn it.
Oh, I hate that.
Okay, mine definitely changed.
Okay, good. Oh, I put the same thing in both places. All right, let's see. It's supposed to be X is the confidence, right? So, sorry, I'm just having a problem copying this data out here.
You're still frozen, Lisa?
It just freed up, so I'm going to try again here.
Nice.
So it's still a hot dog. That doesn't look much like a hot dog to me, though. But
Yeah,
that's okay.
kinda.
Okay, so then what were the questions? Number 9 should be, it was the y-intercept,
Yeah,
should be 18.69.
18.69.
Number 10, the
I'm sorry,
slope should
9.
be 12. Yeah, number 9 should be 18.69.
Okay.
Number 10 should, which is the slope. Come on, move out of the way. Should be 12.6. No, 12.695. Does it say 3 decimal places?
12.695.
12.95. Then what's the question on number 11? It's in
I'm gonna
4.
put
Yeah,
X
when
as
X is
4.
4.
Well, maybe that'll be different. Yeah, it is.
69.469.
Yeah.
Now read
12.
the question again on 12, because it's going to sound different, I think. Can you read the question, Tyson? For number.
It says the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. Predicted value of y for these values of x.
Okay, so if you put a 6 in, right? Because the highest confidence choice is 6. So then it would change to 94.859.
Yeah.
Right?
Because we flipped them before.
Yes.
Okay.
All right, so somebody submit when you're done, and then I'll redo my test.
Okay, and that was the last one. I'll submit, see how it is now.
I'm sorry, I was still trying to get my data in. So number 12.
Yeah, 94.859. But don't submit yet. Let Tyson.
It's 100%.
Okay. All right. We just have to read the dang question. All right. So let me go in quickly and make.
Yeah, we can read them off for you.
I think I wrote them down, but I'm not sure if I wrote them in the right order. Okay. True. True. 2, right? Number 3 is 2. Number 4 is 1.5. Number 6 is 1. I mean, 5 is 1. 6 is hot dog. So funny. 7 is appropriate. 8 is 139. 9 is 18.69. Is that right, Tyson?
Yes.
10 is 12.695.
That's right.
11 is 69.469. 1294.859, and I didn't write these other ones down. It's 1.
Number 13 is 1.
14
Is 1.
1.
And 15
And then
is
the first one, right? The size.
Mhm.
Okay. Save all. All right. Submit, girl. Okay. Good job. 100%.
All right. Well, I'm going to keep working on this, describe the data,
Okay.
and I'll get it turned in tonight, and then I'll just send you guys a copy.
Okay. Okay,
All right.
perfect.
So y'all see what I
Thank you very much for your hard work on that.
Yeah, no
Did
problem.
we lose Tyson?
I haven't
We
heard
lost
from him,
Tyson,
but I
but
haven't.
he'll,
Yeah, he'll
he'll
submit it.
turn it in and do whatever, so.
Yeah.
All right.
All right.
Thank you.
Thanks. We'll see you later.